Hello, this is Ray and
David?
from Calvary Chapel, Boulder City. This is Southern Nevada. I guess this would be a little suburb or bedroom community of Las Vegas. But Calvary Chapel, Boulder City. And David, I have a peanut butter jar I want to talk to you about.
That doesn't look like peanut butter to me.
Okay, well, what I've got here is, and I'm going to try to hold this up to the camera and see what the camera sees. Not quite sure how this will come out, but what I've got here is dirt from my backyard. Like I said, Southern Nevada, home of Boulder City, Hoover Dam, Lake Mead. And so this is Nevada dirt, okay, that I just pulled off of my backyard. And I put it in this peanut butter jar, filled it full of water, punctured some holes in the bottom, shook it up, made a big slurry, and I have just created
a geologic column.
A geologic column. See those layers? Now, okay, this really wasn't my idea. David kind of told me this would happen. And I went ahead and give it a try. I thought, well, no way. Are you serious?
Yeah.
And it worked.
Works great.
Okay. So.
Yeah, try it with your kids. They'll love it.
Yeah. So, all right. So I did this. All right. Now, I have a question that I've thought about, and I'm sure you've thought of, and other people have thought of. You have this evolutionist idea that the index fossils, those fossils being the ubiquitous, all over the world, millions of them, and always found in the same layers, are able to date the layers of the rock. Okay, so you got these layers in the geologic column, and because you find certain fossils in those layers, you're able to date the layers of the rock. Problem is, they come back later and say, oh, well, we know the age of the fossil because of the layer it's in.
Right.
So, all right, that's circular reasoning. You go from the age of the rock to the age of the fossil using the same circular logic.
Sure.
Circular reasoning.
Yeah. Any scientific mind would see quite easily that that is circular reasoning, and even the historical geologists will admit, when pressed, that that is circular reasoning. But they really have nowhere else to go. That is, they made a hard commitment 150 years ago to Charles Darwin's idea of a slow and gradual change in animal life,
so
evolution.
This is 1859.
Yeah. 1859 is right.
Origin of the species. Charles Darwin.
Yes.
Okay.
Yes. Voyage of the Beagle.
Okay. Right.
Yes, but in order to have evolutionary change over time, you need vast amounts of years. And Mr. Lyell, who was a geologist, he presented this idea of interpreting the layers of the geologic column as vast ages of time. That gave Charles Darwin his vast ages to accommodate his changing animals.
So this is pre-1859.
There was a lot of things going on at the turn of the 19th century, and before then. Evolution didn't just pop on the scene. It had been toyed. The ideas have been toyed around with for quite a long time before then.
Okay, interesting.
But the truth is, none of the fossils have dates on them. You won't find a single shell in the geologic column with a date on it.
Okay, but now I got a problem then. All of the smaller fossils, the what the evolutionists would say would be the lesser evolved animals, are found down at the bottom layers, and then all of the more evolved animals are found up at the top layers.
Well, let me change that a little bit. Some of the lesser complex animals are found at the bottom of the geologic column, and some of the more complex animals are found at the top. The truth is, all of the lesser complex animals are found throughout the geologic column, and all the complex animals, at least representatives from each body type of animal, are found throughout the geologic column.
So you got mollusks and oysters and these lower
Yes.
animals at the top.
Yes, and you have vertebrates and invertebrates. You have mammals, reptiles, amphibians, fish, all throughout the geologic column. That is the cold hard truth.
Wow. Okay. So the idea that these index fossils are always found in the same layer is just not true. That is just a convenient way of categorizing, and they're just found in every layer.
Well, they've made it work. When it's presented without any real scrutiny,
Okay.
they don't really allow much scrutiny once they present their discoveries. They find this dinosaur in this rock, and because this fossil was in the near vicinity, then they're going to give it that date. Well, was there any other fossils found in that layer that maybe might disprove your idea? Well, they're not going to discuss that for the most part. When it fits the idea, when it fits the predetermined parameters, there's a lot that has already been invested in these geologic layers and columns. The dates for these layers have already been set for many decades, and they're not going to change them now. I kind of feel sorry for them. They've made their decisions so early on that now it's impossible to change their theories. It really is very difficult to change your theories right now. So
Right.
in that respect, I feel sorry for them, but that's what they've carved out for themselves.
Okay, so I did my little experiment. As I said, I filled this up with water, and there's some holes in the bottom, so this was able to drain out. It took a very long time to drain out, but this is what I got when that happened. On a worldwide flood, I'm guessing you've got 10,000 feet of slurry, of rocks, dirt, ground up deadfall, trees, bushes, leaves, animals, grizzly bears and mollusks and dinosaurs and people. In a worldwide flood, you've got that all grinding up while these tectonic plates are all in action. And is it, do you think, very similar to this? Now, of course, that's all speculation, although the flood is not speculation, but the idea that it's all just sort of swirling and grinding and then settling out, is
Right.
that pretty much how you feel?
Well, the science of hydrodynamics is well defined. The scientists that study what water does and what things do while they're in water.
Right.
Fast moving water, slow moving water, when water is still. Water is a fascinating topic all by itself. Moving water does amazing things. You can get on YouTube and watch a lot of different water events, from flash floods to tsunamis, and see the power of water and what it does.
Yeah.
And the power of water to sort materials is really extraordinary.
And that's what we're talking about here.
Sure. Different size particles, different densities.
Buoyancies.
Yes, absolutely. So if there was, in fact, a cataclysmic flood across the entire planet, it would do tremendous amounts of work. It would erode tremendous amounts of material. It would scour the world clean. It would blend it all up like a giant blender, and then it would redeposit it elsewhere in layers according to its density, its shape, its buoyancy. All of those factors would come into play, and it's a very complex science.
So the
but,
geologic
very predictable.
column is very easily explained by a worldwide flood.
Yes, the truth is that historical geologists who rely on the theories of evolution and deep time for Earth's history, they have the same evidence as biblically based scientists.
Right.
We all look at the same evidence. We all look at the same layers, the same fossils. We all see the same thing. We just interpret them differently. That's okay. We're all humans, and it's great to come to the table and discuss different ideas, as long as everyone gets their chance to speak and present their evidences.
How long would it take? The flood lasted a year. Would this take millions of years, days, weeks? How long would this take to do the geologic column that we see today?
Well, the fact is we don't see the geologic column today. The geologic column that you see in books is really just a theory. It's an idea. It's a drawing.
But you see layers.
There are layers. You can find layers. Go to the Grand Canyon. You'll see lots of layers, but
Right.
you will not see the entire geologic column. In fact, you can go nowhere on this planet and see the entire geologic column. In fact, any layer that you find, if you were able to peel back everything that's on top of it,
Right.
find any layer, and you will eventually find it petering out or gradually transitioning into another layer. You can follow the entire geologic column layer by layer by layer by layer, touching one another, reaching to a fine point and feathering out into another layer in which you can join that one and follow it all the way up to the geologic column.
That's kind of
what you would expect to find if it was all laid down in one event.
That's kind of what I found here. I found that the layers were not perfectly formed. They just
They transition.
they transitioned, and you can't see the same layer across the entire jar. So you're saying this is just sloshing and washing around, and you end up with layers that mix and blend.
Never before in Earth's history has there been an event like this worldwide flood that is presented in the Bible. It was completely unique. What happened under the surface of the water, nobody witnessed. Noah and his family in a boat, they trusted in God. They were inside that boat. They were able to see some of the events going on the outside, I believe. When you read the account of his journey, his voyage in Genesis, you get the feel of a ship's log.
Yeah.
Recording what they saw and what they experienced there. Not in elaborate detail, but giving us a general idea of the progress of the flood from beginning to end. What happened underneath the surface of the water was tremendous. The entire erosion of the surface of the planet, the entire overthrowing of continents, massive earthquakes and volcanic events taking place under the water.
Right.
And all of these things adding to the cataclysm that was Noah's flood. And then as that ended, when that came to an end, all of that had to settle back out. All of those churned up continents and the entire cracked surface of the earth was now going to settle back down into its position where it has remained pretty much the same since then.
And so this could happen in a week. This whole thing, this layering, this settling out of all the slurry could happen in a week.
It could happen much sooner than that.
Really?
Do you remember Mount St. Helens?
Yeah.
1980.
Okay. Right.
That was, I believe it was March of 1980, if I'm not wrong, if I'm not mistaken on that. But I remember Mount St. Helens very well.
Yeah.
Mount St. Helens blew up. One of the largest land movements ever witnessed by man.
Right.
Caught on tape. It was great footage. It's an amazing thing. We can go now to Mount St. Helens Park, and you can go to places where the Toutle River has carved its way down through that freshly laid material. We know exactly when that material was laid down,
yes,
hour by hour,
right,
day by day in the eruption
and
of Mount St. Helens.
It is carved.
And it's layered. The river carved right through those deposits. And you can go there and see an exact replica of what you would find in the Grand Canyon, just on a smaller scale. Layer upon layer of different sized materials that was laid down very quickly. And it's really quite remarkable.
Yeah.
It's just an exact replica of what we see all over the world.
So, vegetation. In Colorado, we have marble beds, and some of the largest in the world, and some of the best pristine white marble. You know, the the Lincoln Memorial was built with Colorado marble, and the Tomb of the Unknowns, some of the whitest, hardest statuary marble in the world. And in some of that marble, you see spidery layers of blue, green, gray vegetation. Basically, it's vegetative layers. And so you got all this white, 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 and then spidery little layers of vegetation. How did that get there?
All around the world, you find vegetation buried under our feet. Everywhere you go, you're going to find vegetation buried in sediment. The fact is that almost the entire surface of the planet is covered in sediment.
Right.
Miles of sediment, material that was eroded and transported and deposited by water.
Right.
And in this sediment, mixed in with the sediment, in layers and compressed, is vegetable material. Some of it is coal. Some of it is fossilized. It has been permineralized and turned into stone, depending on where it is and the conditions under which it was buried. But we find plant material everywhere around the world. And mixed in with those plants, we find also animals.
Right.
Just recently, there was discovered in Canada the most beautifully preserved armored dinosaur that we have ever found. Spectacular thing. It's,
wow.
National Geographic did a great article on that recently.
Yeah.
Of course, National Geographic has the worldview of deep Earth time,
right,
and evolutionary ideas. But the truth is that here was a dinosaur that was going about its normal life,
yeah,
probably munching away inside this forest at one time, and something happened very quickly, very catastrophically, that came through this forest and mowed it down, ripped it apart, carried it along with this dinosaur into where it is now found today in a vast layer of coal. And here this dinosaur lay for the last several thousand years until it was found by a heavy equipment operator.
Right.
They excavated this beautiful dinosaur, did all the prep work on it, and it really is spectacular. It's a
wow,
great, great dinosaur.
So back to Colorado. There is a town in Colorado, Florissant, Colorado. And in Florissant is a very large cache of fossils. I don't know how big this area is. I mean, it's 10 square miles. Apologies if you live in Florissant, have visited this area. It's a fascinating area, but apologies on the size of this, but I'm guessing about 10 square miles. You walk around, it's like a big, huge park. You walk around, and so I asked the lady there, I said, well, if an animal dies, don't the ants and bacteria and all the scavengers just tear it up within a week? How could it be layered? How could it lay there and then rock fall on top of it? Doesn't it get eaten up?
Well, that's a good observation and a very logical question. There's nothing wrong with a question like that. That is a good question. Why is it that there are literally trillions of animals buried under our feet that show almost no evidence of any predation or any scavenging, and in many cases, not even any decay?
Yeah, so the ants didn't come along, eat it up. The bacteria didn't just go to work at it. It was covered and sealed.
Yes, these animals appear to have been healthy and going about their daily lives when they were suddenly, like a snapshot,
right,
buried.
Right.
Each individual case has to be looked at to see the conditions under which that happened. Not all of these animals were buried in the same way,
right,
and with the same speed. Some of them are torn, some of them are broken, some of them I give evidence of having suffocated. They were mineralized in a pose of suffocation. They were gasping for air when they died. Some of them were buried in the very act of giving birth. or in the very act of eating their neighbor.
Right.
It's remarkable. We find fossils all over the world that are so beautiful, so extraordinary, and some perfect snapshots of an animal living its own life and suddenly being snuffed out, buried, and mineralized. And that is, as remarkable as it is, it's actually quite common.
Right, okay.
What could have caused trillions of animals all around the world to have been buried suddenly and mineralized? Something global has to have happened. Very special circumstances are required to avoid decay and predation and scavenging of
Right.
these animals, because
Yeah.
it doesn't happen. Our experience is that doesn't happen in today's world.
Right. It's a little sad, this town in Florissant. From what I understand, 19th century, 20th century, the dinosaur collectors just hit this place. I heard that Andrew Carnegie was a collector, and he went off and bought himself a very large dinosaur for his collection. Other people came along, of course, and I don't know if this happened in Florissant, but certainly in Florissant they came along and just hit that place and took 3/4 of the artifacts and just carted them off to their own homes so that their society friends can come and view them and so on. But that is just one of, I guess, many large caches of fossils, and so I am kind of wondering about these caches. It's not evenly distributed, right? There are large bunches. There was one, I think, in Utah that just north of Vegas here,
Mhm.
and there's certainly the one in Colorado, just large mass graves of all kinds of animals. Is that a common occurrence?
Very common, in fact. I can take you places within 10 miles of where we're sitting right now, where you can hardly walk across the ground without stepping on some type of marine animal.
Right.
Lots of corals, mostly corals, and broken pieces of the animals that lived at the bottom.
Yeah.
Lots of that is around. That's very common. I like collecting fossils myself. I would advise anybody to, when you're collecting fossils, look at your state, county, local laws in your area.
Yeah.
Find out what you can and can't do.
Because of places like Florissant, they got
Yeah.
picked clean.
Some public lands, there are laws that govern it, and it's not forbidden to pick up fossils, but there are rules that govern what we can do and what we can't do.
Sure.
The best thing to do is find private land. There are
Yeah,
places
yeah,
in
get permission
particularly in
and-
Utah, where you can go and pay a fee and go fishing in the rocks.
Sure. Right.
Let's go fishing.
Yeah.
Pull apart these layers of rocks and find fish. The Green River Formation, which covers a lot
So
of
you're
the
talking Green River, Utah.
Green River, Utah.
Okay.
Yes, named
Yeah.
after Green River, Utah.
All right.
The Green River Formation spans many hundreds of thousands of square miles. It's a layer of material, a layer of sediment
Yeah.
that contains in it billions and trillions of little fish. They're called Nitia.
And how big is this area?
Hundreds of thousands of square miles. It's a
Seriously?
layer that covers a vast
Oh, man.
area of the American Northwest.
Right.
And in that layer, you have a lot of fish, big and small. You also have the occasional insect.
Yeah.
You have some reptiles, some smaller reptiles, and there's also been found birds. But most of it is fish.
Right.
Little fossilized fish. You can find them in rock shops. They're pretty common.
Yeah,
There's
okay.
a little fish on a little square of
Right,
sediment.
I've seen
was
that.
brought out.
Yes. The
So there is an example of a vast graveyard of fish, literally billions upon billions of fish. But around the world, there are examples around the world of massive graveyards of animals, mixtures of mammals and reptiles, mixed in with plants and aquatic animals. These layers are many, many tens of feet thick and will cover vast areas of land, hundreds of acres to hundreds of miles. And it's common. There are well-known examples of it around the world.
Right.
Above the Arctic Circle, there are actual islands that are composed mainly of the bodies of animals.
Wow. All right, David, I'm going to call an end to this session. Hope you all enjoyed it. Again, it's Ray and David at Calvary Chapel, Boulder City, Southern Nevada. And hope you enjoyed this edition. We're going to come back because I've just got a bunch of new questions now for you, that things that have kind of sparked my interest. And hopefully we can come back and just ask a few more questions and see it out here on YouTube.
So come and join us again for Science by the Book.
All right.
With Ray and David.
Cool.
Good night.